Hello people, welcome to Night Out Notes. In the previous video, we understood why a database management system is required. Now, before creating any database, there is one important concept that we should understand, and that is data model. A data model is simply a blueprint or an architectural design of a database. Just like an architecture prepares blueprint before constructing a building, a database designer prepares a data model before creating the actual database. A data model explains how data is stored and how it organized and how different pieces of data is related to each other. It generally acts like a guide while designing the database. There is need of this data model very much because it provides the clear structure for storing the data, and it also makes the database to understand and maintain very easily, and it helps to reduce duplicates or unnecessary data. Because of this, almost database is designed using this data models before actual implementation. If there is any errors or so, that it will be rectified before itself. Let's go to the categories of this data model. Based upon the stages in the database design, the data models are divided into three main types like conceptual, logical and physical. The conceptual model is mainly used in the planning stages, whereas logical is used in designing and physical using in implementation stage. So that I have written it like a chart, like planning, conceptual, designing, logical, implementation, physical. While you are writing in your examination, you better draw this diagram so that the examiner will get impressed and make you to give more marks. Let's understand conceptual data model first. It tells us what information should be stored inside the database. Like it focuses completely on the business requirement, like what are all the organization needs. It doesn't think about this tables, this SQL, this storage, everything. This can also be called as high level view because the end users understand the things very clearly. Conceptual data modeling, it mainly identifies three things like entities, attributes and relationships. Entities are all the real world things, like every object, like a person name, age of the person, a duster, a chalk piece, a pen, a paper, everything is considered as an entity here. Here attributes are nothing but the properties of entities. Now when the customer is there, the customer ID, customer name, customer what are all the things he is willing to purchase, all these things considers under the attributes. Whereas the relationships, a customer wants to buy this product, a student enrolls in this course, like we are saying this relationship among this, like customer is buying this product, buying this, and student is enrolling this course, like enrolling. All this comes under the relationship keys. Like it does not include the tables, key storage, as I earlier said, right? This customer is considered as entity, name and email. These are all the properties of the customer, right? These are all called as customers, and the customer placed an order. This is what a relationship meant by. These are all individual things. Don't consider it combiningly. Let's go to this logical data model. Once the business requirements are collected, then next step is to the logical data model. The logical data model describes how the data should be organized. It takes the information collected in the conceptual data model and it converts into this detailed database design. Here, every entity became a table and every attribute became the column of the table. For example, let's consider an online shopping system. In this, the customer entities became the customer table, and order entity became the order table, and product entity became the product table. The customer table contains the customer ID, customer name, customer address, customer phone number. And whereas the order ID contains the attributes and the product details or order details of those order table, and the product table contains those details regarding those product table. And customer ID and product ID inside are having those same primary key as the customer ID and product ID because they are unique itself. Whereas the foreign key in the customer ID and the primary key in the customer ID will be same because for the easy connection between this customer table and order table, whereas product ID and product ID in the product table and order table foreign key is connected using the connectivity in between this order table and product table. Here the important point to remember was logical data model is independent of any DBMS. Like it can be implemented in MySQL server and Oracle server, SQL server or Postgres, anywhere. The logical design remains the same. In this logical data model, it can be represented in different ways depending on how the data is organized. Like first one is hierarchical data model. In hierarchical data model, the data is organized in a tree structure. It follows the parent-children relationship. One parent can have multiple children, but multiple children only have a single parent. There is no such rule like multiple children having the multiple parents like that. In this, only a single parent can have multiple children. It follows like this. Like for example, let me consider a principal. Principal supervises a teacher A and teacher B. And whereas a teacher A acts like a parent to the student A and student B, and teacher A acts like a children to this principal. Like this says as the hierarchical data model. It acts like a one-to-many property. When it comes to this network model, it builds like a graph structure. It is like an improvement to this hierarchical data model where many parents can have many children and many children do have the many parents. For example, a student can work on multiple projects and one project can be assigned to multiple students. Like this way, this network model can work. Like in next thing, entity relationship model, which is also called as an ER model. Instead of creating tables directly, we first draw an ER model. Like it is called as an entity here, and those properties are called as this customer ID and customer name is called as those attributes, and how it is related to those another entity is called as the relationship. Here entity is represented using a square, rectangle, and whereas the attributes are represented using oval, and this diamond shape is representing the relationship between those both entities. This is the most important thing in this whole database, because like after creating those ER diagrams only, it is converted into database tables and during this logical design stage. And ER model helps database designers understand the complete database before implementation. Like it gives the complete glance. See this customer, orders and products, which gives the database designers easy to understand how data is connected to each other. Like every part of data is connected. Like next, relational model. Relation model is one of the most important and primarily used model nowadays, like because everything is represented using tables here. Here rows and columns format. Here the every column, every record is mentioned as a tuple. Different tables are connected using those primary and foreign keys. As it is very simple nowadays in this MySQL, SQL server, Postgres server, maximum of this SQL based things are using this relationship model. Next one, object-oriented models. In this object-oriented models, the data is stored in the form of objects. Instead of this entity, attributes and relationships is in this entity relationship model, the data is stored in the form of objects. Each object contains the data and those methods. Whereas in this example, the shape is the data and this area and perimeter contains like inside this as the methods. And while circle, rectangle, triangle acts like a separate objects with its own individual properties. Mostly these object-oriented models are used under this object-oriented programming environments itself. Next comes our final stage, which is also called as this physical data model or else final stage of this data modeling technique. In this, how and where the data is actually stored is mentioned. Whereas in this conceptual, we know what, and whereas in logical, how, and when it comes to this physical data model, it describes how and where both in the same way. Like this model converts the logical design, what we have in that logical design, into this actual implementation. And it is difficult to understand by the end users because it is in the form of tables and connectivity in between those tables using this primary and foreign key. Like the conceptual data model and logical data model, the physical data model is DBMS dependent because different database systems stores data differently. Here every column is properly assigned with a separate data type. Like it represents the data type using the student ID using the integer data type, and it is also considered as a primary key, whereas name as varchar with the characterization of 50 and all the specifications are represented in this physical data model. The physical data model also consider performance, memory allocation, file organization and storage optimization. Here I said, right, how and where. How it is stored and where it is stored also do matters. Like how means using this data types and the primary key, foreign key representation. Where means in the file system or else the memory allocation, where does it stores. This model is mainly prepared by this database administrator and developer. Physical data model is an advanced method of this logical data model, because whereas in this logical data model we only see the representation part, in this physical data model we also see this implementation part too. This is all about the data models. Hope you like this video. Until then, don't forget to hit that bell icon and subscribe to my channel so that you'll get more informative videos like this. If you found this video really helpful, please like and share. Meet you in another video. Bye bye.